A Harvard scientist just warned the world. Our newest interstellar visitor is shedding metallic alloys that shouldn't exist. Real data confirms a cloud of atomized nickel streaming from the object, but with almost zero iron, a combination that, honestly, just defies natural chemistry. Harvard's own Avi Loeb is sounding the alarm, asking if these aren't natural, what are they? Some whisper it could be engineered. So what is really hurtling through our solar system? Let's explore this together. The discovery of 3I Atlas. Did you know we've only ever confirmed 3 visitors from beyond our solar system? The latest one just rewrote the rules. On July 1, 2025, the Atlas survey team in Chile spotted a faint, fast-moving object. They named it 3I Atlas, signifying it as the 3rd confirmed interstellar object. Right away the math showed this was no ordinary comet. Its path wasn't just a long loop, it was hyperbolic, meaning it was moving too fast for the sun's gravity to ever capture it. This was a one-time visitor from deep space. Astronomers scrambled, finding earlier images of it in data stretching back to mid-June. By the time of its official discovery, it was already inside Jupiter's orbit, blazing toward the sun for a gravitational slingshot that will send it hurtling back into the void. Its incredible speed, roughly 130,000 miles per hour relative to the sun, and its unbound orbit confirmed what the numbers suggested. 3. I Atlas was born around another star and has traveled for an unimaginable time to reach us. Let me explain what makes this more than just a rock. It's a messenger from an unknown star system, and the message it carries is in its chemistry. The nickel mystery. Here's where the story takes a sharp turn into the unknown. Almost as soon as telescopes focused on 3I Atlas, they saw something that shouldn't be there. Data from the Very Large Telescope in Chile revealed a strong spectral line for nickel, a cloud of it vaporizing off the object's core. But what was missing is what has scientists stunned. There was virtually no iron. That's not just unusual, it's unheard of. In every comet, asteroid and meteorite we have ever studied, nickel and iron are cosmic partners. They are forged together in the hearts of dying stars and locked into the same minerals. You don't find one without the other. Yet 3I Atlas is shedding pure nickel vapor, with iron being conspicuously absent. Harvard astrophysicist Avi Loeb, known for his bold theories, was the first to publicly highlight how bizarre this is. He argues that separating nickel from iron on an industrial scale is difficult on Earth. In nature, it's considered next to impossible. This isn't just a small anomaly. The nickel-to-iron ratio in typical solar system objects is well established. On 3I Atlas, that ratio is completely off the charts. It's a chemical fingerprint that matches nothing we have ever seen. Carbon dioxide dominance. Just when the nickel problem had astronomers baffled, the James Webb Space Telescope added another layer of impossibility. When Webb pointed its powerful infrared instruments at 3I Atlas, it found that the gas surrounding the object was overwhelmingly dominated by carbon dioxide. The measured ratio of carbon dioxide to water was a staggering 8-to-1. The highest ever recorded for any comet, whether from our solar system or beyond. To put this in perspective, most local comets have a composition where water is the main ingredient, with carbon dioxide making up only a small fraction. Here the roles are completely reversed. This wasn't a fluke. The readings remained consistent over multiple observation sessions. Some scientists propose that this strange chemistry could be the result of a billion-year journey through interstellar space, where cosmic rays cooked the object's surface. But others, including Avi Loeb, wonder if this is another clue pointing toward an unnatural origin. The second interstellar comet ever detected, 2I Borisov, was also considered chemically unusual for its high concentration of carbon monoxide. But 3I Atlas's carbon dioxide levels are in a class of their own. The Oumuamua precedent. This isn't the first time an interstellar visitor has broken all the rules. Back in 2017, the first ever confirmed interstellar object, named Oumuamua, left astronomers scratching their heads. It was traveling at high speed, had a bizarre, highly elongated shape, and most mysteriously, it accelerated away from the sun without any visible reason. Comets accelerate due to outgassing, where melting ice acts like a thruster, but Oumuamua had no visible tail or coma. This is where Harvard's Avi Loeb first entered the public debate. He controversially suggested that the best explanation for Oumuamua's non-gravitational acceleration was that it was an artificial object, perhaps an alien solar sail designed to ride the pressure of starlight. While most of the scientific community proposed natural explanations, like outgassing of hydrogen ice, or its composition as a nitrogen iceberg, none of the theories perfectly fit all the observations. Oumuamua left our solar system before we could get a better look, leaving a legacy of unanswered questions. Its appearance primed the scientific community to expect the unexpected. Now, with 3I Atlas, we have a second data point that defies easy explanation. Ancient sky metal. Humanity's fascination with strange metals from space is nothing new. Long before we knew about asteroids or interstellar comets, ancient civilizations recognized that some iron fell from the sky, and they valued it more than gold. Take the famous dagger of King Tutankhamun, discovered in his tomb in 1925. For decades its origin was a mystery, but modern analysis using X-ray fluorescence revealed its blade contains nearly 11% nickel and a trace of cobalt, a composition that perfectly matches that of iron meteorites. No iron smelted from terrestrial ore in that era had such a high nickel content. This wasn't a one-off. Iron beads found in a 5,000-year-old Egyptian cemetery also showed the high nickel signature of an extraterrestrial origin. The ancient Egyptians even had a name for this material, iron of the sky. These artifacts show us that for millennia, humans have been working with alloys that didn't originate on Earth. They recognize these materials as special, as gifts from the heavens. Now, as we analyze the impossible alloys of 3I Atlas, we're continuing that ancient tradition, questioning the origin of metals that fall from the sky. Kilonova formation theory. So, if the metals on 3I Atlas are natural, how could they have formed? There are a couple of cosmic forges violent enough to potentially create such exotic materials. The first is a kilonova, the cataclysmic explosion that occurs when two neutron stars collide. These events are among the most powerful in the universe, and for a few brief seconds they create conditions perfect for the R process, a rapid-fire sequence of neutron captures that forges elements heavier than iron. In the chaos of a kilonova, the normal rules of element production can be broken. Some theoretical models predict that the debris cloud from such a merger wouldn't be uniform. Instead, it could contain pockets of matter with strange elemental imbalances, regions that are incredibly rich in elements like nickel, but poor in iron. If 3I Atlas condensed from one of these exotic debris patches millions of years ago, it would carry a chemical signature unlike anything from a standard supernova or our own solar system's formation. This theory provides a potential natural explanation, but it relies on an event that is both incredibly rare and violent. Asymmetric supernova theory. There's another equally extreme possibility, a lopsided supernova. We tend to think of supernova explosions as perfectly spherical blasts, but that's not always the case. Some massive stars die in chaotic asymmetric explosions, flinging different elements in different directions. Astronomers have seen this in action by studying supernova remnants like W49b X-ray observations from NASA's Chandra Observatory show that in W49b, iron is concentrated near the core of the remnant, while other elements were ejected outward in high-speed jets. This proves that nature has a mechanism for separating elements during a star's death. If a star's core collapses unevenly, the resulting explosion can be directional, creating plumes that carry specific elements hundreds of light-years away. It's plausible that 3I Atlas could be a fragment formed from a jet of nearly pure nickel, blasted away from its parent star while most of the iron remained trapped near the core. Like the kilonova theory, this is a natural explanation. However, it requires a very specific and violent type of stellar explosion to create the chemical signature we're seeing. Statistical improbability. Beyond its strange chemistry, there's another red flag that has Avi Loeb and others asking serious questions: the object's trajectory. According to Loeb, the probability of a random interstellar object passing so close to several planets in our solar system, Venus, Mars, and Jupiter, in a single flyby, is astronomically low. His calculations put the odds at about 1 in 20,000, or 0.005%. For an event this rare to happen with only the third interstellar object we've ever detected is, to him, statistically suspect. Furthermore, the object's path is nearly aligned with the plane of our solar system, but it's moving in the opposite direction of the planets. This retrograde orbit allows it to sweep past the inner worlds in a way that looks almost like a survey mission. To add to the suspicion, 3I Atlas reaches its closest point to the Sun on the far side from Earth, making it incredibly difficult for us to observe when it's most active. Critics argue that in a vast universe, rare events are bound to happen. But Loeb counters that when multiple anomalies, the metals, the chemistry, and the trajectory, all point in the same strange direction, the possibility of an artificial origin must be taken seriously. The Golden Record Parallel. In 1977, NASA launched the Voyager 1 and 2 spacecraft, each carrying a golden record. This was a project led by a team chaired by Carl Sagan, intended as a message in a bottle cast into the cosmic ocean. The records contain sounds, music, and images portraying the diversity of life and culture on Earth, designed for any intelligent extraterrestrial life that might one day find them. Sagan famously said the act of launching this bottle says something very hopeful about life on this planet. The Golden Record is a time capsule, a physical object carrying information across vast distances and times. Now consider 3I Atlas. It's an object carrying materials with a chemical composition so strange it looks like a deliberate signal. This has led some to draw a parallel. What if 3I Atlas is its own kind of golden record? Instead of a message encoded in grooves on a disk, perhaps the message is written in the very atoms of the object, in the unnatural ratio of its elements. It's a sobering thought. We sent a message out into the void, trusting that matter could carry meaning. What if someone else had the same idea? Atomic messages. If 3I Atlas is a message, how could it be written? The answer might lie in isotopic encoding. Isotopes are versions of an element with different numbers of neutrons. On Earth, scientists can already store information at the molecular level by creating unique isotopic fingerprints. By precisely controlling the ratios of different isotopes in a material, you can create a pattern, a kind of atomic QR code that would never occur in nature. An advanced civilization could theoretically bake a message into a metallic object, making it durable enough to survive a journey of millions of years through interstellar space. Such a message would be immune to the cosmic noise that can degrade radio signals. The information would be in the fine print of the object's chemistry. This is why every scrap of data from 3I Atlas is being scoured for these hidden patterns. Are the isotope ratios what we'd expect from a kilonova, or do they show a level of order that points to intelligent design? We're not just looking for a rock anymore, we're looking for a signal hidden in matter itself, a message that has waited eons to be read. Right now, we stand at a crossroads. Is 3I Atlas a product of nature at its most extreme and exotic, formed in the heart of a cosmic catastrophe we can barely imagine? Or are we looking at something else entirely, a piece of technology, a messenger, or maybe a calling card from a civilization beyond our own? The data from the Very Large Telescope and the James Webb Space Telescope has broken our existing models and forced us to confront possibilities once relegated to science fiction. The search for answers is just beginning, and the next discovery could change everything we know about our place in the universe. Don't forget to like, subscribe, and hit the bell icon for more deep dives into cosmic mysteries. Thanks for watching Future Facts.